Good afternoon, students. Yes, very good afternoon to all of you. Let's begin our class. Limits. Let's continue from where we left in the last class. Okay. So have a look at the next question, question number 23. Limit extends to 0, x tan 2x minus 2x tan x divided by 1 minus cos 2x whole square is equal to. So here, limit extends to 0, x into tan 2x. Tan 2x is there now. I will write tan 2x as 2 tan x divided by 1 minus tan square x minus 2x tan x whole divided by this 1 minus cos 2x can be written as 2 sin square x whole square. Okay. So now this is equal to limit extends to 0. Here, if I take it inside, it will become 2x tan x. So I'll take that as common. 2x tan x. Then what will remain? 1 by 1 minus tan square x minus 1. See, from this factor 2x tan x, I have taken 2x tan x as common from these two. So this is what will remain. Now 2 square, that would be 4. Sin square whole square, that will become sin power 4x. Okay. So now in this sin power 4x is there now. So I will write it like this. 2 1s are 2 2s are, that gets cancelled. Limit extends to 0. I'll write like this. X by, here 2 is there, sin x into tan x divided by sin x into, now take LCM here. 1 minus tan square x is the LCM. So numerator will become 1 minus 1 plus tan square x divided by 1 minus tan square x whole divided by sin square x. See, here you have 4 into sin power 4x. That 4 we have cancelled. 2 1s are 2 2s are, 2 is remaining. Sin power 4x, I am writing it as sin x, and sin square x. Now, as x approaches 0, this x by sin x becomes 1. Tan x by sin x will also becomes 1. How? Tan x by x is 1. Multiply and divide by x here. Similarly, multiply and divide by x in the denominator. Sin x by x, that will be 1. X gets cancelled. So this 2 will give you 1. Okay. So now we have limit extends to 0. Here 1 gets cancelled. Tan square x divided by 1 minus tan square x you have. 2 into 1 minus tan square x into sin square x. That much we have. This 1 minus tan square x and this sin square x. Now as x approaches 0, tan square x divided by sin square x, this much will become 1. Okay, 1 square, which is 1. And for the other things here, for this tan square x, if I put x as 0, tan 0 I'm getting, which is 0. So the answer will be 1 by 2. 1 by 2, which is the third option. Okay, 1 by 2 is the correct answer. Then let's have a look at the next question. Question 24. Limit extends to 0. Sin x grades divided by x. Grade. So grade is another unit of measurement of angles. Just like, so we know 2 of them. The radian measure and the degree measure. Grade measure is 1. So what is that grade measure? That let me discuss before solving this problem. Okay, so how do you define a degree? A degree is defined as a right angle is divided into 90 equal parts. Okay, so a right angle, this is divided into 90 equal parts. Each part is called a degree. Okay, then how do you define radian? Radian is the angle subtended by the center of by an arc of a circle at the center of a circle whose arc length is equal to radius of the circle, then that angle is called 1 radian. Okay. Then the relation between them is equal to, you know, this pi radian is equal to 180 degree. These are the two measurements, you know. Okay. So now, in terms of grades, what they do is, one right angle is divided into 100 equal parts. Each part is called a grade. One right angle is divided into 100 equal parts, and each part is called a grade. Okay. So that means 90 degree is equal to 100 grades. Right? So 180 degree is equal to 200 grades. So from there we can write pi radian is equal to 200 grades. Remember this formula. Just like, you know, how the relation between radian measure and degree measure, pi radian equal to 180 degree. In the same way, pi radian equal to 200 grades. That you remember. Therefore, from this we can write pi by 200 radian is equal to 1 grade. So x grade can be written as pi x by 200 radians. Pi x by 200 radians. So just like x degree, we write x degree as pi x by 180 radians. So x gradient, x grades can be written as pi x by 200 radians. Okay. So why do we use that conversion here is because one of them is in grades and the other one is in radians. So it is better to convert this grade to radians. So that will give you limit extends to 0, sine of that x grade can be written as pi x by 200 radians divided by x. This x is there, no? Here sine theta is there in the numerator, means we want theta in the denominator. Here pi x by 200 we have, here we have only x. So multiply and divide by pi by 200. So as x tends to 0, sine theta by theta. As theta tends to 0, sine theta by theta is equal to 1. When x approaches 0, this pi x by 200 also approaches 0. So sine pi x by 200 divided by pi x by 200 becomes 1 into this pi and pi by 200. That will give you pi by 200. 1 into pi by 200, which is equal to pi by 200, which is the fourth option. Okay. Next, 26th question. Limit extends to pi by 4 cos x minus sin x divided by pi by 4 minus x into cos x plus sin x. Okay. So for this problem, I can rewrite it like this. Limit extends to pi by 4 cos x minus sin x divided by pi by 4 minus x into limit extends to pi by 4 1 by cos x plus sin x. Okay. So as you know, I'm using this formula. Limit extends to a f of x into g of x. This can be written as limit extends to a f of x into limit extends to a g of x. Whenever we want to apply the limit for the product of two functions, we can apply the limit individually for those two functions. Separately we can apply, and then we can take their product and then we can multiply. Okay. So why I'm doing so is because directly, see, this will be 0 by 0 cos pi by 4 minus sin pi by 4, that is 1 by root 2 minus 1 by root 2 divided by pi by 4 minus pi by 4, 0 by 0. But here we are not going to get 0, we are going to get a finite quantity there. That simplification will be easy. So I will apply the limit separately. Now here in this case, I'm explaining in detail, but in the exam, you need not do all these things. Directly, you can write cos pi by 4, sin pi by 4. Okay, see, I'll keep this as it is before I simplify. limit extends to pi by 4 cos x minus sin x divided by pi by 4 minus x. Here apply the limit. Cos pi by 4 1 by root 2, sin pi by 4 1 by root 2. 1 by root 2 plus 1 by root 2 is 2 by root 2. That will be root 2. So this will give you 1 by root 2. Okay. So that's equal to that 1 by root 2 I will take out. Now here in this case, if I apply the limit, here if I apply the limit directly, I'm going to get cos pi by 4 minus sin pi by 4. Cos pi by 4 minus sin pi by 4, that is 0. Denominator pi by 4 minus pi by 4 is also 0. This is 0 by 0 and indeterminate form. So use L Hospital's rule. We get minus sin x minus cos x divided by minus 1. The derivative of pi by 4 minus x is minus 1. So that is equal to 1 by root 2. Apply the limit now. Here minus 1 by root 2 minus 1 by root 2 divided by minus 1. That's equal to 1 by root 2 into minus 1 by root 2 minus 1 by root 2. That will give you minus 2 by root 2, which is minus root 2 divided by minus 1. That will give you root 2. Root 2 gets cancelled. Hence, the answer is 1. First option, second option is the answer. Okay, see, actually writing this first step is not necessary. You can skip this first step. Just to make you understand, I have written this. So directly, for this factor cos x plus sin x, for this factor cos x plus sin x, directly you can apply the limit and take it outside. Okay, but cos x minus sin x, you cannot take it outside. Why? Because there you are getting 0. So then 0, if I take out it here, denominator is 0, it is an indeterminate form. If it is non-zero finite, if any factor is there which is non-zero and finite, you can apply the limit and directly take it out. Okay. Then 28th question. The value of limit extends to infinity x into tan inverse of x plus 1 by x plus 2 minus cot inverse of x plus 2 by x is. Okay. Right. Now, I will write the given problem in this way. Limit extends to infinity x into tan inverse of x plus 1 divided by x plus 2 minus tan inverse of x divided by x plus 2. X divided by x plus 2. How? Cot inverse x can be written as tan inverse of 1 by x. So cot inverse of x plus 2 by x can be written as tan inverse of x by x plus 2. Now I will use tan inverse x minus tan inverse y formula. What is tan inverse x minus tan inverse y formula? Tan inverse x minus tan inverse y from inverse trigonometric function. That is equal to tan inverse of x minus y. That means x plus 1 by x plus 2 minus x divided by x plus 2. X minus y divided by 1 plus xy. X plus 1 by x plus 2 into x divided by x plus 2. X minus y divided by 1 plus xy. Okay. Now, this is equal to limit extends to infinity x into tan inverse of, simplify this. Here LCM is same, x plus 2. So numerator will be x plus 1 minus x. That will be 1 divided by x plus 2. Denominator x plus 2 whole square plus x into x plus 1 divided by x plus 2 whole square. Okay. So here one of those x plus 2 gets cancelled. Other x plus 2 will go up. So this is equal to limit extends to infinity x into tan inverse of x plus 2 divided by, expand this x plus 2 whole square, that will give you x square plus 4x plus 4 plus x square plus x. Okay, that's equal to limit x tends to infinity x into tan inverse of x plus 2 divided by, look here, we have x square plus 4x plus 4 plus x square plus x. Add them. What do we get? 2x square plus 5x plus 4. Okay. So now I will divide this by x plus 2 divided by 2x square plus 5x plus 4. Okay. Since I have divided, I have to multiply also. X plus 2 divided by 2x square plus 5x plus 4. Now, as x tends to infinity, this much will become 1. How it will become 1? Let me explain. So, there is a formula. I think I have not told you so far. Now, I'll explain. Limit x tends to 0, tan inverse x by x is equal to 1. How it will be 1? Let us see. If I directly apply the limit as x tends to 0, I'm getting tan inverse 0 here. What's the value of tan inverse 0? 0. Divided by 0. I'm putting x as 0. So you're going to get tan inverse 0 by 0. 0 by 0, an indeterminate form. So when it is of the form 0 by 0, we usually go for L'Hospital's rule. Yes, differentiate this. Derivative of tan inverse x is 1 by 1 plus x square, and derivative of x is 1. Put x as 0 now. So this will give you 1 by 1, which is equal to 1. Okay. So now you may be thinking, sir, here it is 0, but here we have infinity. How can you use that formula? Now you just observe, given x is tending to infinity. When x tends to infinity, as x tends to infinity, what will happen to x plus 2 divided by 2x square plus 5x plus 4? Just observe. When x approaches infinity, what will happen to x plus 2 divided by x square plus 5x, 2x square plus 5x plus 4? Look here, numerator and denominator both are polynomials. Both are polynomials, and the degree of the denominator is larger. Denominator has a larger power. When x tends to infinity and the degree of the denominator is larger, then this will tend to 0. If the degree of the numerator is larger, it will tend to plus infinity or minus infinity. If the degrees are equal, then the value will be the coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator. Now that degree of the denominator is larger, when the degree of the denominator is larger, then this will tend to 0. Okay. So that means here writing x tends to infinity is as good as saying x plus 2 by 2x square plus 5x plus 4 tending to 0. So therefore, this much can be expressed as, can be written as 1. So then what is, we are left with what? Limit x tends to infinity. Here there is an x. Into this will give you x square plus 2x divided by 2x square plus 5x plus 4. Okay. Apply the limit. Now you observe both are polynomials of the same degree. When both are polynomials of the same degree, then the answer is coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator, which is 1 by 2. 1 by 2 is the answer. Okay. Did you understand, or do you feel that I should explain this again? Okay. Sunita says no. No, sir, understood. Okay. Explain once again, sir. Okay. So as expected, look here. First, I'm writing cot inverse x plus 2 by x as tan inverse of x by x plus 2. And then I am using the formula tan inverse x minus tan inverse y. Tan inverse x minus tan inverse y. that will be equal to tan inverse of x minus y divided by 1 plus xy. I'm using this formula. So by using that formula, tan inverse x minus tan inverse y is equal to tan inverse of x minus y divided by 1 plus xy. This is what you will get. Here you simplify. We have a common denominator here in x plus 2. So I just need to subtract the numerator. X plus 1 minus x, where x gets cancelled, 1 will remain. Here in the denominator, we have 1 plus x plus 1 into x divided by x plus 2 into x plus 2. So x plus 2 whole square, their simplification. One of those x plus 2 gets cancelled. Other x plus 2 will go to the numerator. Then on simplification, you get x into tan inverse of x plus 2 by 2x square plus 5x plus 4. Here I am dividing by x plus 2 by 2x square plus 5x plus 4. Since I am dividing by that, I have to multiply also. So to compensate it, I am multiplying by x plus 2 by 2x square plus 5x plus 4. Okay. So now as x approaches 0, this x plus 2 by 5x, 2x square plus 5x plus 4 will tend to 0, tend to infinity. Sorry. As x tends to infinity, this will tend to 0. So I'm using this formula, limit x tends to 0, tan inverse x by x is equal to 1. So this entire factor, tan inverse of x plus 2 by 2x square plus 5x plus 4, that will be equal to 1 because of this formula. Limit x tends to 0, tan inverse x by x equal to 1. Okay, see here we have x tends to infinity. When x tends to infinity, this x plus 2 by 2x square plus 5x plus 4 will tend to 0. So writing limit x tends to infinity is same as writing this much tends to 0. Hence this factor becomes 1. Now you have x here and here you have x plus 2. When I multiply x square plus 2x, denominator is 2x square plus 5x plus 4. Now both are polynomials of the same degree. Hence the answer is 1 by 2. Okay. Now let's move forward. 29th question. If f of x is equal to sine of 1 plus step x divided by step x for step x not equal to 0, and it is 0 for step x is equal to 0, where step x denotes the greatest integer not exceeding x, then limit x tends to 0 minus f of x is equal. So we are asked to find out only the left hand limit here. Limit x tends to 0 minus f of x. That means limit x tends to 0, f minus x is approaching 0 from left side. There it is defined as sine of 1 plus step x divided by step x. Limit x tends to 0 minus sine of 1 plus step x divided by step x. Okay. So now x is approaching 0 from left side, means x is very close to 0 but less than 0. So I can take x as say minus 0.1. If I take x as minus 0.1, then what happens? Step of minus 0.1. Step of minus 0.1, that will be equal to minus 1. 1 minus 1, it will be 0. Sine 0 in the numerator. Denominator, step of minus 0.1, that will be minus 1. Sine 0 is 0. 0 divided by minus 1 will be equal to 0. That's all. We are just asked to find out the left hand limit, and the left hand limit is 0. Okay. Then go to the next question. 32nd question. Limit x tends to infinity x plus a by x plus b whole power x plus b. Okay, so you just look at the base here. Forget about this power. You just think of this x plus a by x plus b. When you look at this, as x tends to infinity, what will be its value? Observe that both are linear factors, x plus a and x plus b, which means both are polynomials of the same degree, which is 1. So if that is the case, then as x tends to infinity, its value will be the coefficient of x here divided by the coefficient of x in the denominator, which is 1 by 1, that is 1. And power, we have x plus b, and as x tends to infinity, power tends to infinity. So this will be of the form 1 power infinity. Okay. So it is of the form 1 power infinity. When it is of the form 1 power infinity, then I have given you one formula. What is that formula? The formula is this will be equal to limit extends to suppose if you have limit extends to a f of x to the power g of x. If it is of the form 1 power infinity, then this will be equal to e to the power limit extends to a g of x sorry, g of x into f of x minus 1. So I can use that formula here. So if we use that formula, we are going to get e to the power limit extends to infinity g of x is x plus b into f of x minus 1. F of x is x plus a by x plus b minus 1. E power limit extends to infinity g of x into f of x minus 1. Okay, so let us further simplify this. E to the power limit extends to infinity x plus b into, here take LCM. LCM is x plus b. This numerator is x plus a minus of x plus b. That will give you minus x minus b. X gets cancelled. So this is equal to e power limit extends to infinity x plus b into a minus b divided by x plus b. This x plus b gets cancelled. So we will have e to the power limit extends to infinity a minus b. When x tends to infinity, what will happen to a minus b? Nothing will happen because it's a constant. Whether x tends to infinity or 0 or somewhere else, a minus b will remain as a minus b only. So the answer is e to the power a minus b. E power a minus b, which is the third option. E power a minus b. Okay. Let's go to the next question, which is question number 34. If a, b, c, d are positive real numbers, then limit n tends to infinity 1 plus 1 by a plus bn whole power c plus dn is equal to. If a, b, c, d are positive real numbers, then limit n tends to infinity 1 plus 1 by a plus bn whole power c plus dn is equal to. Now, if we directly apply the limit 1 plus 1 by a plus bn. Observe here numerator is 1, denominator is a plus bn. It's a linear factor here, denominator, numerator is a constant. So as n tends to infinity, this much will tend to 0. Okay, so 1 plus 0, that is 1. Base will be 1. And power c plus dn we have, as n tends to infinity, it will tend to infinity. So again in this problem also, it is of the form 1 power infinity. So when it is of the form 1 power infinity, I have given you that shortcut. The shortcut is e power limit extends to a g of x into f of x minus 1. So by using that formula, this will be equal to e to the power limit extends to a, means in this case limit n tends to infinity g of x. So what is g of x here? C plus dn into f of x minus 1. 1 plus 1 by a plus b and f of x minus 1. So 1 gets cancelled. So we have e to the power limit n tends to infinity c plus dn divided by a plus bn. C plus dn divided by a plus bn as n tends to infinity. Okay. So look at this c plus bn divided by a plus bn. Both are polynomials of the same degree. Okay, both are polynomials of degree 1. When both are polynomials of the same degree, then the value of that limit is equal to the coefficient of highest power of x in the denominator. In this case, it is n. Coefficient of highest power of n in the numerator divided by the coefficient of highest power of x n in the denominator. So which is d in the numerator and b in the denominator, so it will be d by b. Hence the answer will be e to the power d divided by b. E power d by b is the answer. E power d by b, which is the first option. Okay, then look at the next question, which is question number 35. 35. Limit extends to 0, 10 power x minus 2 power x minus 5 power x plus 1 divided by x into tan x. If we directly apply the limit, 10 power 0, that is 1, minus 2 power 0 is also 1, 1 minus 1 gets cancelled, minus 5 power 0, which is 1 plus 1. So that also gets cancelled. Denominator also 0. So we get 0 by 0. Usually I say whenever we get 0 by 0, we go for L'Hospital's rule. But this is an exception because it's somewhat complicated to differentiate it. I mean, that x into tan x product rule you have to use. It will take more time. Instead, I would suggest another method. I'll write 10 to the power x as 2 to the power x into 5 power x. Okay. Minus 2 power x minus 5 power x plus 1. Divided by x into tan x is there. I will write that as x into tan x by x into x. I'll make it as x squared. Here what I did is I have divided by x and multiplied by x. Okay. So as soon as I saw that tan x, as I know when x approaches 0, tan x by x becomes 1. So I divided by x and then multiplied by x. Okay. So limit extends to 0, tan x by x becomes 1. This factor you need not write in the next step because this will become 1. Now let us simplify that numerator. Numerator, I will take 2 power x as a common factor between the first two terms. So what will remain? 5 power x minus 1. From the next two terms, I will take minus 1 as common. Then what will remain? 5 power x minus 1 divided by, in the denominator we have x square. Okay, that's equal to limit extends to 0. This can be written as 2 power x minus 1 into 5 power x minus 1 divided by x square is there. I'll write one x here, another x here. X square can be written as x by x. Now observe this, limit extends to 0, 2 power x minus 1 by x. It is of the form limit extends to 0, a power x minus 1 divided by x. A power x minus 1 divided by x, when x approaches 0, that will be equal to log a. So the first factor will give you log 2. And second factor here, observe this, 5 power x minus 1 divided by x. As x approaches 0, that will be equal to log 5. Log 2 into log 5 is the answer. Don't further simplify, not possible. Don't write this as log 10 or log 7, etc. So observe, third option is the answer. Log 2 into log 5. I'm using the formula limit extends to 0, a power x minus 1 divided by x is equal to log a. Okay, then limit extends to 0, x into 10 to the power x minus x divided by 1 minus cos x is equal to. If we directly apply the limit, 0 into 10 power 0, 10 power 0 is 1, 0 into 1 is 0, minus 0, numerator is 0, denominator 1 minus cos 0, cos 0 is 1, 1 minus 1, 0. 0 by 0 is an indeterminate form, but I shall still not use L'Hospital's rule because differentiating that x into 10 power x will consume more time. So I will take that x as common. If I take x as common, what will remain? 10 power x minus 1 will remain. In the denominator, I'll keep it as 1 minus cos x. Now 10 power x minus 1 is there. So this looks very similar to the previous one. A power x minus 1. When you have a power x minus 1 in the numerator, we would prefer x in the denominator. So here you have 10 power x minus 1 in the numerator. So you should prefer x in the denominator. So I will multiply and divide by x. Okay. I'll make this as x square and this as 10 power x minus 1 by x. I have multiplied and divided by x. Divided by 1 minus cos x. Now as x approaches 0, 10 power x minus 1 divided by x is equal to log 10. Okay. Limit extends to 0, x square by 1 minus cos x, this much will remain. Into from this 10 power x minus 1 by x, as x approaches 0, that will be equal to log 10. Okay, because limit extends to 0, a power x minus 1 divided by x is equal to log a. So this will be log 10. And you know the value of this, x square by 1 minus cos x as x approaches 0. You know, actually I gave you this formula. Limit extends to 0, 1 minus cos x divided by x square. Its value is equal to 1 by 2. Now it is x square by 1 minus cos x, so it's reciprocal. Its reciprocal is 2. So the answer is 2 log 10. Log 10, which is the second option. Okay. Next question. Question number 38. Limit n tends to infinity 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by etc. plus 1 by next term will be 5 into 7 etc. and so on till 1 by 2n minus 1 into 2n plus 1 is equal. N is tending to infinity now, right? So now I will write like this. Limit n tends to infinity 1 by 2. I'll multiply and divide by 2 for each of these terms. 2 divided by 1 into 3 plus 2 divided by 3 into 5. Next term will be 2 divided by 5 into 7. And so on. Finally, 2 divided by 2n minus 1 into 2n plus 1. Okay. I have multiplied and divided by 2. That's equal to limit n tends to infinity 1 by 2 into this 2 by 1 minus 1 by 3 2 by 1 into 3 is there now. It's nothing but 2 by 3. I'll write a 2 by 3 as 1 minus 1 by 3. And 2 by 3 into 5 can be written as 1 by 3 minus 1 by 5. Observe, 3 into 5 is nothing but 15 here. So it is 2 by 15. Here you take LCM. LCM is 15. Suppose I want to find out this 1 by 3 minus 1 by 5. What do? I'll take LCM. LCM is 15. 3 5s are 5 into 1. 5 minus 5 3s are 3. 5 minus 3. 2 by 15. Right? So that 2 by 15 here we have. I am writing that as 1 by 3 minus 1 by 5. Plus. In the same way, 2 by 5 into 7, which is 35. 2 by 35 is there. I'll write that as 1 by 5 minus 1 by 7. Okay. Here 1 by 5 minus 1 by 7, if you simplify 7 minus 5, 2 divided by 35. So 2 by 35 can be written in this. And so on. Here what happens, you can write this as 1 by 2n minus 1 minus 1 by 2n plus 1. How? Take LCM. LCM is 2n minus 1 into 2n plus 1. Right? LCM is 2n minus 1 into 2n plus 1. Numerator will be 2n plus 1 minus of 2n minus 1, which means minus 2n plus 1. 2 and 2n gets cancelled. 1 plus 1, 2. 2 divided by 2n minus 1 into 2n plus 1. Okay, 2n minus 1 into n plus 1 can be written in this way. 1 by 2n minus 1 minus 1 by 2n plus 1. Now observe, here you have minus 1 by 3, here plus 1 by 3. Here minus 1 by 5, here plus 1 by 5. Here minus 1 by 7, the next term will be plus 1 by 7. Next term will be 1 by 7 minus 1 by 9. Then 1 by 9 minus 1 by 11. Plus 1 by 11 minus 1 by 13. And so on. Okay. And the last term is 1 by 2n minus 1 minus 1 by 2n plus 1. So you can cancel all these terms. Everything gets cancelled except the two terms, except the first and the last term. Okay. So we have limit n tends to infinity 1 by 2, right? Limit n tends to infinity 1 by 2 into what is remaining 1 minus 1 by 2n plus 1. 1 minus 1 by 2n plus 1. That's equal to limit n tends to infinity 1 by 2 into, take LCM, LCM is 2n plus 1, this numerator will be 2n plus 1 minus 1, 1 gets cancelled, this 2 gets cancelled. So you are left with the limit n tends to infinity, n tends to infinity, n divided by 2n plus 1, okay. 1 got cancelled, then you have 2n by 2 into 2n plus 1, then 2v got cancelled. So limit n tends to infinity, n divided by 2n plus 1. Now both are polynomials of the same degree. Both are polynomials of degree 1. Okay. Hence the answer is the coefficient of highest power of n in the numerator, which is 1, divided by the coefficient of highest power of n in the denominator, which is 2. Hence the answer is 1 by 2. Second option. Did you understand? Any doubt with respect to this question, this particular question? Okay, so I'll explain again. See, first step, what I did is I have multiplied and divided by 2. Okay, so for every term. That 1 by 2 I have taken out a multiplication, I have multiplied by 2. Multiplied 2 to each and every term there. Okay, so 2 by 1 into 3 plus 2 by 3 into 5 plus 2 by 5 into 7 and so on till 2 by 2n minus 1 into n plus 1. Okay. Now I am writing that 1 into 3 is 3. 2 by 3 I am writing that as 1 minus 1 by 3. And 2 by 15 is there. 3 into 5 is 15. 2 by 15 can be written as 1 by 3 minus 1 by 5. Then 2 by 35 can be written as 1 by 5 minus 1 by 7. And so on. Okay. So now alternatively, all these terms get cancelled. Here minus 1 by 3, there plus 1 by 3. And minus 1 by 5 plus 1 by 5, minus 1 by 7 plus 1 by 7, etc. All these terms gets cancelled except the first and the last term. First term is 1 and the last term is 2n plus 1. 1 minus 1 by 2n plus 1. So on simplification, that will become 2n plus 1 minus 1 by 2n plus 1. 1 gets cancelled, then 2 gets cancelled, n by 2n plus 1, and both are polynomials of the same degree. So the answer is 1 by 2. Okay. So some of you may be having a doubt. Vinith has a one. So the doubt is that, sir, when you explain, we do understand that. But how do we get to know that we should divide by 2 only? There are so many other numbers as well. How do we realize that we should divide by 2 only? Why not by any other number? Okay. So for that, I'll give you another way how you can solve this. Okay. So I'll take that nth term. Let me call that as T. What is the nth term? 1 by 2n minus 1 into 2n plus 1. Okay. So now what you need to do is, in order to solve, evaluate such limits, you need to split this as 2 terms, where first term, let me say A divided by this linear factor plus B by the second linear factor 2n plus 1, right, like this. A by 2n, A by one linear factor plus B by another linear factor. There are two linear factors here. Okay. So now multiply this equation by 2n minus 1 into 2n plus 1. Multiplying by 2n minus 1 into 2n plus 1. Okay. So when we multiply by this LHS will be 1. RHS here, 2n minus 1 gets cancelled. 2n plus 1 will remain. Plus B into. Here what happens when I multiply by 2n minus 1 into 2n plus 1? That 2n plus 1 gets cancelled. 2n minus 1 will remain. Okay. Now you need to get the values of A and B by putting some value for n. First, I would like to find the value of A. In order to get the value of A, I have to make the second term as 0. Second term can be made 0 by putting n is equal to 1 by 2. So in this equation, I'll put n equal to 1 by 2. Then what happens? 1 is equal to A into. Put n equal to 1 by 2. 2 into 1 by 2. That is 1 plus 1. So 2 plus B into 0. So this means that 2A equal to 1, which will imply that A is equal to 1 by 2. Okay, not enough space. Now I want the value of B. For that, I have to make this as 0. So put n is equal to minus 1 by 2 now. When I put n is equal to minus 1 by 2, we get 1 is equal to A into here. When I put n is equal to minus 1 by 2, 2 gets cancelled, minus 1 plus 1, that is 0. Plus B into, put n as minus 1 by 2, 2 gets cancelled, minus 1, minus 1, minus 2. Which means 1 is equal to minus 2B, which implies B is equal to minus 1 by 2. Okay. So A is 1 by 2 and B is 1 minus 1 by 2. That you substitute in this equation. What do we get? 1 by 2 divided by 2n minus 1 plus minus 1 by 2 divided by 2n plus 1. I'll take 1 by 2 as common. So 1 by 2n minus 1 minus 1 by 2n plus 1. 1 by 2n minus 1 minus 1 by 2n plus 1. Okay, so this is the nth term we got. Okay, look here. Nth term we got Tn is equal to 1 by 2 into 1 by 2n minus 1 minus 1 by 2n plus 1. Now we want Sn, right? I want the sum of all this. That is nothing but T1 plus T2 plus T3, etc. till Tn. That's equal to T1. Put n as 1. 1 by 1 minus 1 by 3 plus T2. Put n as 2. 1 by 2 into 1 by 3. When I put n as 2 here, 4 minus 1, 3 minus 4 plus 1, 5. 1 by 5. Plus, put n as 3. 2 into 3, 6 minus 1, 5. Minus 1 by 7, etc. The last term, 1 by 2 into 1 by 2n minus 1 minus 1 by 2n plus 1. Take 1 by 2 as common. And then minus 1 by 3 plus 1 by 3 minus 1 by 5 plus 1 by 5. Everything gets cancelled. So then you will have 1 by 2 into 1 minus 1 by 2n plus 1. Then the simplification you know. Okay, this is another way of doing it, which is called partial fractions. This is the actual method. But here by observation, okay, by observing it, we can write it in this way. The idea is to ensure that we cancel as many terms as possible. Yeah, alternative method is too long. That is why I gave that shortcut, multiplying and dividing by 2. How do we get to know whether we should multiply and divide by 2? See, our job is to cancel the alternate terms, right? So how do I cancel? 1 minus 1 by 3 plus 1 by 3 minus 1 by 5. In this way, if I do, I can cancel. Okay, so if it is like this, then I can cancel. But in order to cancel this, here we get 2 by 3, here 2 by 15. But what we have is only 1 by 3 and 1 by 15. That 2 is missing. So we multiply and divide by 2. Okay. So I think it's clear now. Okay, fine. Let's move forward. 40th question. Okay, now I'll take a very simple problem. Concentrate here. As the level of difficulty increases, I can see the number of participants decreasing. So they're inversely proportional. Okay. So as the time is also a factor, that is also inversely proportional. Okay. So look at question 40. Limit n tends to infinity 1 plus 2 plus 3 up to n terms into 1 square plus 2 square plus 3 square up to n terms divided by n into 1 cube plus 2 cube plus 3 cube up to n terms. Okay. So limit n tends to infinity 1 plus 2 plus 3 up to n terms. So you know the formula, n into n plus 1 by 2. Then 1 square, 2 square, 3 square up to n square. That is equal to 1 square, 2 square, 3 square up to n square is equal to n into n plus 1 into 2n plus 1 divided by, what is the formula? 1 n into n plus 1 into n plus 1 divided by 6 whole divided by n into 1 cube, 2 cube, 3 cube up to n terms. That is equal to n square into n plus 1 whole square divided by 4. Okay, so let us see what and all we can cancel. Here n gets cancelled, 2 n into n plus 1 gets cancelled. Here another, this n into n becomes n square, that n square, this n square gets cancelled. Then n plus 1 into n plus 1, together it will become n plus 1 whole square, that gets cancelled. Okay, so 2 1s are 2 2s are, this will remain. Okay, after that 2 1s are 2 3s are. So what will remain now? Limit n tends to infinity. In the numerator, 2n plus 1 is there. In the denominator, here 3 is there, here n is there. Together it will become 3n. Limit n tends to infinity, 2n plus 1 divided by 3n will remain. Now both are polynomials of the same degree. So the answer is coefficient of highest power of n divided by the coefficient of highest power of n. 2 by 3 is the answer. Okay. 2 by 3. Okay, then let's move forward. Question number 41. Limit extends to infinity x to the power n by e power x is equal to 0 for n equal to 0 only, n is any whole number, n is 2, n equal to 2 only, and no value of n. Oh. Let us observe. Limit extends to infinity. I'll put different value for n. Okay. So first I will put n is equal to 0. If I put n is equal to 0, then what happens? X to the power 0, which is 1 by e power x. Now as x tends to infinity, what will happen to e power x? When x approaches infinity, e power x will also approach infinity. Okay. So look at the graph of e power x. I will draw a rough sketch of e power x. E power 0 is 1. So something like this. So this is the graph. As extends to infinity, it goes up beyond the screen and goes up to infinity. So denominator is infinity. 1 by infinity, this will tend to 0. Okay. That means when n is equal to 0, this limit will be equal to 0. N is equal to 0, it is true, but they have given n is equal to 0 only. So unless we know what happens at the other values, we cannot tell anything. So at n equal to 0, clearly this limit is 0. Suppose if n is equal to 1, then what happens? Limit extends to infinity, x divided by x power 1, that is x, by e power x. Now if I apply the limit, I am going to get infinity by infinity. infinity by infinity means you can use L'Hospital's rule. So if I use L'Hospital's rule, differentiate this 1 by e power x. Okay. So now also this will tend to 0, right? 1 by e power x as x tends to infinity, e power x tends to infinity. Hence 1 by e power x will become 1 by infinity, which means it will tend to 0. So for n is equal to 1 also it is true. Then if I take n is equal to 2, then what happens? Limit x tends to infinity. You're talking about x tends to infinity, x square by e power x. If we directly apply the limit, we are talking about infinity by infinity. So I prefer L'Hospital's rule, which will give you 2x divided by e power x. Okay, still it is infinity by infinity. Use L'Hospital's rule again. That will give you 2 divided by e power x. Okay. Now if I apply the limit as x tends to infinity, we get 2 by infinity, which tends to 0. That means for n is equal to 2 also it is true. For n equal to 3 also. In the same way, you can prove that it is true for any whole value of n. Okay, whenever n is a real number, n is any whole number. Okay, because see, when you have the, this x power n you have divided by e power x is there. If you directly apply the limit, it is becoming infinity by infinity. So we use L'Hospital's rule. Once you differentiate, you are going to get n into x power n minus 1. The denominator will always remain as e power x only, because the derivative of e power x is e power x itself. So again, if you use L'Hospital's rule, you just observe the power of x in the numerator, it goes on decreasing. After every time when you use L'Hospital's rule, that means every time when you use differentiation, when you differentiate it, the power of x goes on decreasing, and at some point it should reach 0, right? So suppose if you are talking about x power 10, then x power 9, x power 8, x power 7, etc. So it will reach x power 0. That means a constant. Whereas look at the denominator. Denominator is always e power x only. So at some point the numerator becomes a constant and the denominator will always remain as e power x. So then if you apply the limit, it will be like 1 by infinity, which means it tends to 0. Okay. So the answer is n is any whole number. Okay. There. Next question, 44th question. For a greater than 1, limit x tends to infinity, a power x minus a power minus x divided by a power x plus a power minus x is equal to limit x tends to infinity. A power x minus a power minus x divided by a power x a power minus x. Okay. So if you directly apply the limit, a power infinity, that will be infinity, minus a power minus infinity, that will be 0. How? A power minus infinity is nothing but 1 by a power infinity, that is 1 by infinity, which will tend to 0. Similarly, this will be infinity plus 0, so you get infinity by infinity. Don't cancel them. Don't write 1 by 1. That's not correct. I mean, 1 may be the correct answer, but not because of this reason. We cannot cancel infinity. So directly we cannot evaluate this limit. And using L'Hospital's rule is not such a good idea. Okay. So limit extends to infinity. A power x minus a power minus x is there. So I'll write that as 1 by a power x. Here a power x plus 1 by a power x. Now I will take a power x as common here, in both in numerator as well as in denominator. I will take a power x as common. Then what will remain? 1 minus 1 by a power x whole square divided by a power x 1 plus 1 by a power x whole square is there. This a power x gets cancelled. Now as x tends to infinity, this a power x will tend to infinity. X tends to infinity implies a power x tends to infinity. Therefore, 1 by a power x will tend to 0. Its square is also 0. So the answer will be 1 minus 0 divided by 1 plus 0, which is equal to 1. Which is equal to 1, which is the first option. Okay. Okay, students, with that, I will end today's class. I shall not test your patience because I feel most of you have lost your patience. So I'll stop at this stage, and those who don't have any doubts can leave the meeting. And those who have any doubt, please stay back and post your questions in the chat box. 26th question. Okay. So here, limit extends to pi by 4 cos x minus sin x divided by pi by 4 minus x into cos x plus sin x is there. If I directly apply the limit cos pi by 4 minus sin pi by 4, that is 0. Denominator also pi by 4 minus pi by 4 is 0. Now what I am doing here is I am grouping them separately. This I am considering as one problem and this as another problem. So limit extends to pi by 4 cos x minus sin x by pi by 4 minus x into limit extends to pi by 4 1 by cos x plus sin x. Okay. So here if I apply it is becoming 0 by 0. So I'll wait for one more step here. And here if I apply cos pi by 4 1 by root 2 sin pi by 4 also 1 by root 2. 1 by root 2 plus 1 by root 2 will give you 2 by root 2, which is root 2. So 1 by root 2. Now here it is 0 by 0, right? If I directly apply 0 by 0. So this 1 by root 2 I have taken out. So I am using L'Hospital's rule. Derivative cos x is minus sin x. Here minus cos x divided by derivative pi by 4 is 0. Derivative minus x is minus 1. Apply the limit 1 by root 2 into minus sin pi by 4 minus cos pi by 4 divided by minus 1. This will be minus 1 by root 2 minus 1 by root 2 will give you minus 2 by root 2, which is minus root 2 divided by minus 1, that is root 2. Root 2 gets cancelled. Hence you get 1. Okay. Then 41st question, one doubt from 1. 41. Limit extends to infinity x to the power n e power x equal to 0 for n equal to 0 only, n is any whole number, n equal to 2 only, no value of n. Okay. So I'm putting different values for n. First I'll put n equal to 0. If I put n equal to 0, x power 0, that is 1. 1 by e power x. Okay. Now as x tends to infinity, e power x will also tend to infinity. And then 1 by infinity will tend to 0. That means what they have given, they have already given that it is equal to 0. The question is, for what value of n this is true? So we observe that when n is equal to 0, this is true. Then when we put n is equal to 1, we are going to get x divided by e power x. As x tends to infinity, it is of the form infinity by infinity. So we can use L'Hospital's rule. Differentiate x, you get 1. Differentiate e power x, you get e power x itself. Now when we apply the limit as x tends to infinity, so e power x is tending to infinity. So 1 by infinity, that will tend to 0. So for n is equal to 1 also, it is true. Then if I take n is equal to 2, limit extends to infinity x square by e power x. There if I apply the limit as x tends to infinity, we are going to get to infinity by infinity. So I'll use L'Hospital's rule, 2x by e power x. Still it is infinity by infinity. I'll use L'Hospital's rule again. So it will become 2 by e power x. Now as x tends to infinity, e power x tends to infinity. So you have 2 by infinity, which will tend to 0. So we observe that the result is true for n equal to 0, 1, 2, etc. Hence, the result is true for any value of n, when n is any whole number. Okay. Next doubt is 38th question, second step. Multiply and divide by 2. Okay. So here you have 2 by 3. Here you have 2 by 15. Here you have 2 by 15. Sorry. 2 by 35, etc. I'm writing 2 by 3 as 1 minus 1 by 3. Writing 2 by 5, 15 as 1 by 3 minus 1 by 15. 1 by 3 minus 1 by 15. Take LCM. 15 is the LCM. 3 5s are 15 minus, sorry. This 1 by 3 minus 1 by 5. LCM is 15. 3 5s are 5 here. 5 3s are 3 here. 5 minus 3. That is 2 by 15. Okay. So I'm writing 2 by 15 as 1 by 3 minus 1 by 5. Similarly, 2 by 35 can be written as 1 by 5 minus 1 by 7. 23rd question. Okay, so whoever is asking this 23rd question, I can understand that you have joined later. Okay, anyway, let me answer. So limit extends to 0, x into tan 2x minus 2x tan x divided by 1 minus cos 2x whole square we have. X into tan 2x. I'm writing tan 2x as 2 tan x divided by 1 minus tan square x minus 2x tan x. So here you have x, here you have 2 tan x. So together 2x tan x. That 2x tan x I am taking as common. Okay. Meanwhile, denominator 1 minus cos 2x, we can write that as 2 sin square x. Okay. So 2x tan x, if I take out, here first term will contain 1 by 1 minus tan square x. Second term will contain 1. So 1 by 1 minus tan square x minus 1 divided by 2 sin square x whole square, that will become 4 sin power 4x. Okay. So now 2 by 4, 2 ones are 2 2s are, so 2 will remain in the denominator. Sin power 4x, sin power 4x, I'm writing it as sin x into sin x into sin square x. Okay, sin x into sin x into sin square x, right? So now as x approaches 0, x by sin x will be 1. Tan x by sin x is also 1. Here take LCM, 1 minus tan square x is LCM. Numerator will be 1 minus 1 plus tan square x. 1 1 gets cancelled. Okay. So you have 2 in the denominator. Here tan square x divided by 2 into 1 minus tan square x. This 2 is in the denominator. Okay. Into sin square x. As x approaches 0, tan square x by sin square x will also become 1. And this tan square x, when I put x as 0, tan square x 0 is 0. 1 minus 0 is 1. 2 into 1 is 2 in the denominator, 1 in the numerator. So 1 by 2. 17th question. 17th question is not here. Ask in the group, but there I'll explain. Once again, explain 24th question. X grade. Okay. So you remember that pi radian is equal to 200 grades. So 1 grade is equal to pi by 200 radians. X grades is equal to pi x by 200 radians. Pi x by 200 radians. Okay. So I'm converting x grade to radians. Sin pi x by 200 radians. So now sin theta, when you have sin theta in the numerator, we would prefer theta in the denominator. So I have divided by pi x by 200. Okay, pi by 200. X is already there. So since I have divided by pi by 200, I had to multiply by pi by 200. So this much will become 1 as x approaches 0. This quantity will be 1. 1 into pi by 200 will give you pi by 200. Fourth option is the answer. Okay. So another doubt is 29th question, related to 29th question. Instead of if they have given 1 plus step of 1 plus step of sin x, 1 plus step of sin x, okay, divided by step x, I would assume. If this is the case, then what is the answer? That is his doubt. So now limit x tends to 0 minus. When x approaches 0 from left side, what happens to sin x? Look at the graph of sin x. Graph of sin x. This is the graph. X is approaching 0 from left side. So x is very close to 0 but less than 0. So there it will be around, it will be negative. Minus, this is minus 1, right? And this is 0. So clearly it is in between minus 1 and 0. So step of this would be minus 1. Minus 1 plus 1, 0. Okay. So you are going to get step of 1 minus 1 divided by minus 1. This is 0 by minus 1 is equal to 0. Okay. So in that case also you will get the answer as 0 for left hand limit. Right hand limit does not exist. 26th question. Okay, just now I have explained that. Sir, in 38th question, the second step, how 2 divided by 1 into 3. It's not 1.3, it is 1 into 3. Okay, so it is 2 by 3. 2 by 3 can be written as 1 minus 1 by 3 now. Take LCM. 3 is the LCM. Here 1 3s are 1, 3. 3 minus 1, 2 by 3. Question number 17 in level 2, that is true, but it is not here. I will answer in the group. Okay. So then question number 28, I think I have answered. Where is 28? Here. Limit x tends to infinity x into tan inverse of x plus 1 by x plus 2 minus cot inverse of x plus 2 by x plus 2 by x. Okay. I'm writing cot inverse of x plus 2 by x as tan inverse of x by x plus 2. Then here I'm using tan inverse x minus tan inverse y formula, which is equal to tan inverse of x minus y divided by 1 plus xy. That on simplification will give you this. Here x plus 2 is the common denominator. Numerator will be x plus 1 minus x. X gets cancelled. So 1 by x plus 2. Denominator, the LCM is x plus 2 whole square. This numerator will be x plus 2 whole square plus x plus 1 into x. Okay. So then one of those x plus 2 gets cancelled. Other x plus 2 will go up. So on simplification, you will get x into tan inverse of x plus 2 by 2x square plus 5x plus 4. I'll divide by x plus 2 by 2x square plus 5x plus 4. And then I'll multiply by the same. Okay. So now as x tends to infinity, this x plus 2 by 2x square plus 5x plus 4 will tend to 0. So then I'm using this formula. Limit x tends to 0, tan inverse x by x is equal to 1. So by using that formula, we can say this factor is equal to 1. So then we are left with x into that, x into x plus 2, that will give x square plus 2x in the numerator. In the denominator, we have 2x square plus 5x plus 4. Okay. So now that's equal to, both are polynomials with the same degree. So 1 by 2 is the answer. The last 3 steps. Okay. So here, if I apply the limit, this is 0 by 0. So use L'Hospital's rule. Derivative of cos x is minus sin x. Derivative of minus sin x is minus cos x. Derivative of pi by 4 minus x is minus 1. Apply the limit as x tends to pi by 4. Then simplify. You will get the answer. Okay. Question number 28. I have answered. 38. 38. Okay, answered on several occasions. Okay, with this, I will stop today's class. Further, if you have any doubts, you ask me in our WhatsApp group. Okay, thank you.